Can you hear me? Cool, thank you. Okay. What can you see now? Okay, cool. So this is going to be a short one. I couldn't actually create much more of a deck myself, but it's going to be good enough. So highlights first, things that happen well, we started driving performance improvements with the data and with the help of development. This means that we are starting to use all the data we have currently with on performance because we actually have a lot of data. We created a lot of issues for development to start working on them. We're concentrating particularly on SQL now because we have a lot of pages that can be improved just by fixing SQL queries. And they're all scheduled for 9.0, which means that soon enough we will have performance improvements. Next thing is that we created public monitoring, monitor GitLab.net, which was the old black box monitoring. Now, any dashboard that we have in the private monitoring that we want to publish, we just need to label it as public and it will just get there. It will take an hour or so, but automatically it will be published. This has already been quite nice because we can share dashboards, live dashboards with people from outside GitLab by sending direct links. I will tell you that if whenever you want to publish something into an issue, use the public monitoring because then people can actually see the same thing we're seeing and we don't need to paste images. Again, some things are in the private one, but try to use monitor GitLab.net all the time instead of the private one. And finally, we had a really awesome team behavior when we had the database disaster, the crisis. And I'm just really happy about that we behave as a real team. And that was quite good. Now, current concerns. Backups. That's top priority right now. That's what we need to worry about right now. And sorry, come again. And we need to get into a situation where we're confident enough about our backups. And that covers not only the database, but also the file system. And that means that there is a lot of data that we need to take care of. Second concern, the infrastructure is too rigid and monolithic. It means that it's actually hard to make any changes to the infrastructure. This is one of the things that I saw, and this is one of the reasons why we had so many problems before getting into the database crisis. The database crisis was basically an escalation of a lot of different issues. And one of them is that whenever we want to make a change in the infrastructure, it is hard. It's error prone, it's easy to make a mistake, and it's easy to make a change and not seeing it in production, which means that it's a little bit out of control. And we need to take care of that, which means that we need to restructure how are we managing the infrastructure. And we're doing a really bad use of infrastructure resources. We started to work on this by using Terraform, but there seems to be a lot of machines that we're not really aware of. It seems that there are a lot of services that are in a machine because why not? And we can make a way better use of resources and save a lot of money by doing so, and also have less problems. And the team dynamics. This is something I want to take care of, and this is me particularly. It seems like we are in a constant state of alert and alarm, which means that we jump into the next fire way too soon, leaving things unfinished, which means that we don't document all the things we should be documenting. We don't test all the things we should be testing, and many things get unanswered, and issues are not closed because we miss those final steps of leaving a good trace on how to troubleshoot and how to maintain things over time. This is a specific thing about the infrastructure team, the production team particularly, and I'm going to be working on this personally. Need help. Disaster recovery. We need help with this, which means that particularly for Git and shared files, I know that there is some progress going on here, but we need to make this scalable as soon as possible. Basically because any backup system we want to handle or manage, and so to say it simply, we need to back up 60 terabytes of data, and it's hard to make it incremental. Therefore, we need to get this wired into GitLab itself. So we dogfood it ourselves, and we use this technology to get ourselves into a sane situation. This is not specifically about the database. This is about the rest of the files. And I think that this is something we can actually ship to our customers to help them and to get a better disaster recovery tooling from our own problems. Plans. This is ongoing yet. We will have we are working right now and having a quick and dirty backup using Azure Blob Snapshots. And there's more ongoing here. Next thing I want to work is I want to have a continuous backup recovery strategy, which means that I want to have continuous backups to S3 using probably WAL-E. And then I want to reuse this as a way of actually recovering all the time, so we can actually run migrations on these recoveries. So I want to leverage the way development itself as a way of testing backups. So we make sure that we can recover because we're doing it all the time, right? And that was exactly the problem we had. We never tested backups or recovery, sorry. I want to also get into a continuous infrastructure provisioning with Terraform, because right now, as I said before, the infrastructure is too rigid. It's too hard to make changes to it. So I want to get into the point where we can provision infrastructure first at the host level with Terraform. There, afterwards, I want to start using containers. But containers are something that has to happen after we have the infrastructure under control. And finally, I want to restructure Chef from the ground up, because this is one of the reasons why it's so rigid and so hard to manage. And that is pretty much all I have. So, any questions?
What does restructuring Chef entail?
It entails, sorry?
Kubernetes?
Not really, not initially. Initially, it's hard to actually change the structure of the fleet because everything is really tightly coupled. So we need to start dividing things first. It's not getting to the big refactor in the sky, because that's not the way to do that. It's just slowly starting to isolate things so we can start managing the infrastructure in isolation, and then we can start replacing it. On the long run, I do see Kubernetes, but we have to get there.
I mean, the second part of that, I mean, we have a lot of cookbooks that are legacy cookbooks. I mean, I think that's what Pablo was talking about when we talk about things like this, is we have a lot of cookbooks that are like, for example, up until 2 months ago, all of our HA proxy configuration was managed from a cookbook called GitLab NFS cluster. Just because it used to be historically, everything ran on the NFS nodes, and that was the way things were done. And things just kind of like grew and grew and grew, right? So we've been slowly going through and like separating things out, making sure that we've got functional pieces where we now have rules that apply and cookbooks that are just for our HA proxy fleet. And now we're pulling out other things that are rules that just apply to how we manage other aspects of it, so that we can have clean separation, so that when we start introducing things like build dependencies and build processes for, you know, Kubernetes and containerization structure, that it's possible, and we're not building it on old cruft, is I think what we're going for there.
Yeah, and there's also the fact that we don't have a way of testing a change in a cookbook without getting to production. So I see that it makes you happy.
I'm going to say
Ben.
that that's difficult because the design behind Chef, and I've never heard of anybody actually making Chef capable of being tested before production in terms of unit testing, a configuration, or deployment change.
Which is fair, in which case we probably need to reconsider keep using Chef or whatever.
So the question on the chat was, we have unit testing
Yes.
of the cookbooks, but unit testing still doesn't, it only gets you part of the way. And basically my observation has been that Chef the unit testing is actually quite nice, but the end-to-end testing of Chef is basically impossible. It's just not a testable infrastructure, which is why people are going with things like Kubernetes, because you can fully end-to-end test your pods before they hit production.
Yeah, the thing is that to get there, we first need to understand exactly what are we doing. We need to split all these monolith into parts that we can start moving out of Chef or out of, I mean, we need to get this infrastructure in a way that it actually makes sense.
Nicola, how can we help from the platform team in the disaster recovery stuff that you mentioned?
It is still ongoing. My thinking is that I would like to actually use the feature, and I would like to help making it monitorable, so we can actually use it in production, and we're confident that it works, because that's going to help the customers actually. And we should be probably the first customer here.
Okay. Is there an existing issue on it or something that I can just get up to speed on it? Would you mind just
sure.
sending it over?
Okay, I can look it up.
Thank you.
Thing to say, we need to start doing disaster recovery testing, but if we can't move 60 or 70 terabytes off of Azure, how do we really do it?
At this stage, rsync probably is the best way to go. It's tricky. It's tricky, and we will need to basically find a good way to do it. I haven't thought about exactly how to do it. I know that actually Google has some tools to extract information. At least that's something they mentioned in a meeting not so long ago. But the best way I can think of, so if we want to migrate out of Azure right now, using GEO in a way that it actually works will be great, because it will be basically a continuous move, and that will be awesome. The rest of the things we need is basically move the database, which can be done with streaming replication. And the next thing is all the shared files, which would mean that we should basically split it, move whatever is not being modified, and then just keep a final drive for whatever's left. But that, rsync. Okay, question from, first of all, question from Jim. Is that Prometheus? Yes. And then you said that will our existing architecture scale any better at Google? I don't think that it's a provider problem at this stage particularly. I think it's much more of a set of decisions that we made in the application that made it harder to scale. But also we are in the point where we need to start changing a lot of things on the way we do, because we cannot keep running it as a monolith. We need to start splitting it out and split all these specifics of the application to get some performance out of it. Does it mean that Google can provide a better, I see Ben suffering a little bit. It doesn't mean that Google can probably offer better performance, but we need to change a little bit our architecture. We should stop using NFS, for example. It's just not going to scale.
Yeah, there's actually, I don't think NFS is that big a problem. The biggest difficulty here is the way Git interacts with disk, and Gitly is going to solve a bunch of that. And caching will solve a bunch of that. And database sharding, yeah, that can also help with a bunch of this. There's lots of small things we can do. Switching to Google GCP is going to provide no better scaling than switching to bare metal. Some of the fundamental things is dealing with the data partitioning, and that's the hard thing that's going to make things scale.
But that's application.
Yes, that's all application changes.
Yeah. It's not that there's no silver bullet here.
No. At least not yet.
No. Yes.
Things like Ceph can provide some silver bullet if it actually worked. Things like distributed databases can provide a silver bullet if they actually worked. And depending on the architecture, range-based sharding proxies or bucket-based hash bucket-based sharding proxies can also help. But these are all difficult to implement with the way. Well, they're not all difficult to implement. It's just they require a bunch of changes that we're not ready to make yet.
And also, it means that we will be coding something that makes sense for a customer as large as us, not so much for the rest of the customers, because small customers do not need that level of scale. So we are in that point where we need to start taking care about these kind of things. But I'm not so sure that the customer actually has this need.
Jim, you asked about architectural changes before we move. As Sid was saying in some of the posts, the real reason to move and migrate from one cloud provider to another or to bare metal has nothing to do with speed or architecture. It has entirely to do with costs. And moving from Azure is more about cost than anything.
That said, solve architectural changes before we move elsewhere. I don't think that's, so some of the architectural challenges are going to need to happen eventually. Migrating is going to be a big distraction, yes. I don't think that this week we're in a position to actually even consider that.
Pablo, I think it's worth also saying that Gitly is part of the solution there. So if we get like all the Git data going through Gitly, then Gitly, we can basically migrate, and once we remove that abstraction that we have sort of directly onto NFS, we can start moving repositories one at a time from one cloud provider to another, and Gitly can take care of routing those requests. Gitly can be part of the solution with that.
As long as latency permits, yes.
Yeah. But it's either that or like go offline while we be 60 terabytes or whatever it is.
Is that therefore you're going to get some form of streaming replication on an offline site. So I would rather use that approach than just pushing all the Git data away.
I think you'd have some. I mean, it's something to talk about.
Absolutely.
There's many options, but I think abstracting away so that it's not application service writing to NFS file systems.
Oh yeah, I know.
Help with that.
I really know that. Yes, Jim, we're thinking about this long term. Any more questions? Okay, crickets to 1, crickets to 2, crickets to 3, solved. See you in the 10 meeting in 7 minutes. Bye.
Bye.